Hi everyone, welcome to this workshop with Chris MacInnes. My name is Rebecca Edwards. I'm the curator at Arbeit Gallery in London. If this is your first time with us, Arbeit Gallery is a gallery that commissions artists working at the intersection of digital practice, new technologies and critical thinking. Arbeit Skills, which is the programme of which this workshop is part of, launched in 2020. And Arbeit Skills are introductions to creative software and short course classes on digital theory and software that are led by artists and curators working in the digital realm. These creative courses were kind of made to fill a gap we saw for short but in-depth peer-to-peer learning, something in between a YouTube tutorial and a university short course, all via a supportive network of like-minded people. The classes are always small, which gives you and other participants a chance to receive a more personal and hands-on approach in a more friendly and engaging environment. And the main aim of the workshops is for you guys to leave with skills that you can apply within your creative development. So giving the second of 3 special workshops made in collaboration with the Serpentine is Chris MacInnes. So these workshops have been, as I said, made in collaboration with the Serpentine, but also with their second iteration of future art ecosystems, which is something that Eva will talk to you a little bit about in a second. But firstly, quickly about Chris. So Chris, I'm just going to introduce you. I hope that's okay. So Chris takes computing and networks as a starting point for works with software, hardware and organisms. Using the diverse vectors of our planetary networks, Chris attempts to trace the mycelic tangle of chaotic phenomena across platforms, landscapes and biosynthetic ecologies. So today Chris will be taking you through some exciting dynamic behaviours you can play with in Unity. So Eva, I'm just going to hand over to you now, and yeah, if you can introduce yourself and future art ecosystems too.
So my name is Ava Yeager. I'm Associate Curator at Serpentine Galleries, where I work with the R&D platform team. Alex joins us today from my team. We work on an initiative to kind of operationalize the artistic research that we work with. And we're also producers of Future Art Ecosystems, an annual strategic briefing. And the idea behind this work is to provide concepts, references, language, and arguments that can be integrated into operational agendas for 21st century cultural infrastructure. On July 6th, the team, along with a lot of contributors, published the second issue of Future Art Ecosystems, Art and Metaverse. And this time around, we focused on how metaverse infrastructures might interface with the art world. The metaverse, for those of you who are less familiar with the term, is an always online, persistent, spatial sort of second world. And we think that it represents a fundamental shift in our notion of digital systems and presence, and it requires new skills in order to grasp its implications. So I'll drop the link to the free report. So as part of our exploration into virtual experiences, we wanted to bring you a series of technical workshops focused on art making in the metaverse, specifically for artists and art practitioners. So last session, we worked with Danielle Braithwaite-Shirley to develop the foundations of our own game. So who we were making a game for and how they would be brought into the game, what the tools for interaction would be. And then today we're moving into the game engine to explore dynamic environments in Unity. I think I mentioned already all of the sort of housekeeping details, so I'll just hand it over to you, Chris.
Hello, it is me. I am Chris. As Rebecca said, I'm an artist. I'm also a technician, which I think is important, is like as much a part of my art practice, and my art practice is as much a part of me being a technician. Two things sort of exist chaotically together. So I'm going to try and make this workshop really simple, and it's just to try and kind of open the door a little bit to what a program like Unity can do and what you could do with it. We might not get as far. We'll see how we go. Everybody might take to it amazingly, and we might get really far. But also, I'm aware that kind of working with these things is a little intimidating to begin with. There's a lot of controls. There's a lot of lingo. There's a lot of concepts that might be, I don't know, initially a little hard to wrap your head around. I would try, to the extent that you can, I would try not to worry about it too much. There's going to be a lot of stuff that just doesn't make a lot of sense for a long time. There certainly was for me when I was learning this stuff. And maybe like a year in the future, it will click, but it might not right now. So as long as we can get something working, don't worry about whether you understand it or not. I'm just going to try and share my screen so that we can see. So this is the kind of thing we're going to try and make. This is a little, I've got this super smashing little ghost here. You can see him or her or it, them. And I can click places and it will kind of wander around. I've also made myself a little pet dragonfly that if I walk over to, it starts following me about. It's quite slow, probably needs to be a bit faster. There's also these little eyeballs which kind of roll around, which are quite interesting, but we'll get to why that's interesting. Like there's also this horrendous thing of me as a AA battery, which is probably the most upsetting thing I've ever made. But what's going on here is I'm using one single like tool from Unity, which is this thing called nav mesh agents, which is basically a form of built-in AI for Unity, which has a lot to do with pathfinding. So you can define a bunch of things, and then these characters or objects or whatever they are will try and navigate landscapes you build for them. So it's a really interesting way to build, and relatively simple way to sort of start building systems. And you can see here that I've kind of added all of this, you know, we've got a little bit of animation, we've got the bobbing of the ghost, we've got a light on this one. These guys are kind of funny because they're actually all trying to follow each other, which results in them kind of freaking out a little bit, but they behave quite strangely, which is quite fun. They've all started in diverse positions and now they seem to have all converged on each other. But this is all using this one sort of relatively simple kind of tool that you can mess with in all kinds of different ways, and I think break in some quite interesting ways as well. So this is where we're going to try and get to. We might not get this far. We might only get to the point of controlling one object or making something patrol around, but we'll see how far we get. So this is the interface we're going to be working with. We're also going to be working with Visual Studio Code, which you should have been able to install. But if you couldn't install it, it's not such a big deal. You can just use whatever code editor. In the case of this is Unity. This is what it looks like. We're going to be working with sort of 3-4 panels here. Everything else you can pretty much ignore. On the left-hand side, this is everything that's in my scene, which is like my level, my game level. You've got a camera, which is up here. You've got the objects, a sphere there for the eyeball. You've got all kinds of other stuff. You've got the floor. You've got a couple of lights. Everything that's in the scene is here. you can see that things are sort of nested, and that's to do with stuff being parented, which is a convenience thing that we'll sort of get to later. On the right, we have this inspector window, which is just kind of like properties for your objects. So whatever you highlight, I've got a lamppost here. The lamppost has basically no properties, it just has a position. And you can see you can change these things as you like. Other things will have more complex sort of properties. This one has a script on it. It also has this nav mesh module. And you kind of build up the behaviors of objects by adding these components. And those are added and sort of controlled from this right-hand panel. There's also up here on the right, if you see this other tab, just here, this is the navigation panel. You probably won't have this yet by default, but we'll go through the process of setting that up in a sec. This is where we kind of control a whole bunch of things about how it decides where the things can move to and where they can't. And it looks very complex, and you can do some pretty complex things with it, but we're going to keep it pretty simple, so try not to worry too much. And then down the bottom, this is our kind of assets folder. This is basically a file browser. This is everything that we have in our game. So I've been unusually tidy and tidied things into different folders. I've got my materials in one folder. I've got some models in another folder. I've got the scene, which is just the whole scene, the level. And then I've got a folder of scripts. And these are scripts that I've written that do different things. And this is where anything you kind of add to the game, you import it in here by importing an asset, and then you grab whatever it is and import it, and then you can use it in your scene or however you want to use it. Apart from that, the only other thing you really need to know is up the top, there's this play button, there's a pause button, and that's about the extent of it. Anything else you shouldn't need to touch. If you do touch it, don't worry, we'll try and sort it out, but this is the sort of, these are the main areas, and that's kind of what we're going to be working with. So we're going to make a new project, and I'm using just the newest version, which is 2020.3.3. If you have 2020.3.4 or 2020.1, then it's fine. So I'm going to make a new one, and I'm going to make a I'm going to make a 3D project, and I'm going to give it some kind of name, and I'm going to call it Super Smashy Game. And I'm going to, if you want to save it in a particular place, then the location is the place to do that. So I'm going to save it in my Unity projects folder, and then I'm just going to hit create, and then we should get an empty project. All right, so this is what Unity looks like. Let's try a bit of moving around. So I'm hoping that most of you, or at least some of you, will have played video games before, and will be aware of the WASD convention for moving around. It's essentially the arrow keys, but on the left-hand side. So if you look at your keyboard, you've got W, A, S, and D, and they're kind of in a similar shape to the arrow keys. So W is forward, A is left, S is backwards, D is right. And if you right-click in this central window and hold, you can see you can move the view around like you're a character, like you're in a game. And if while you're holding right click, if you press W for forward, S for backward, D for right, and A for left, you should be able to move around the scene, and you can sort of fly around. I mean, there's not much to fly around at the moment, but you can fly around. So that's how we're going to kind of make our way around the environment. So let's get into adding some objects. If you hover in the hierarchy window, which is where all of our scene stuff is, we're going to create a new thing. And you do that by just right clicking in that panel. And then you can see here, we've got 3D objects down there at the bottom of the list that comes up. And then you can just select a plane. So I'm just going to add a plane. And for reasons that aren't clear to me, Unity, for some unholy reason, just spawns objects often in like random places. I don't know why this is. I've never quite figured it out. But we want the ground to be at 0 position, like right in the middle of the scene, so that we're not like creating a world that's really weirdly off to the right hand side or something. So if you have a look in the inspector window, which is the panel on the right, you can see there's this the top sort of section is transform, and this is all our kind of information about the position, the rotation, and the scale of our object. So I'm just going to set mine to my position to 0 on the X, 0 on the Y, and 0 on the Z, just so I have it right in the middle of the scene. And I'd also like to make it a bit bigger. So I'm going to set the scale to be, yeah, all right. I'm going to set the scale to be 10 on each of the axes. So X is 10, Y is 10, Z is 10. Okay, and now we have a ground, which is great. This is the beginnings of wonderful things. You can see that it is horrendously bright in this world. Again, I don't know why this is. It's absolutely blinding. So you should all have a little sun in the middle, roughly in the middle of your scene. So we can click on the little sun, or if you can't find it, you should be able to see it in your hierarchy list. It should be called directional light or something. So we're just going to click on that so that we can access its properties on the right. And let's just turn down the intensity to something less extreme. I'm going to turn down the intensity of mine to 0.2. So can everybody see that when you select the light, it has some properties named light, and one of those is intensity. Okay, so we've got a plane. Let's create something to move across the plane. So we're going to create our player. And we're going to do this by adding a new object. So in the same manner, right click in the hierarchy panel on the left. And then what we want to do is we want to create an empty. And I'm going to call that empty player. So you see how you can rename it by clicking on this name on the name of the object. I'm just going to call it player so that I'm not totally confused. And I'm going to do the same thing that I did with the floor. I'm going to set the position to 0, to 0, and to 0. Thusly. Okay. So, and obviously this is going to be the thing that we put all of our kind of control onto. And so that when we kind of come to make it into our amazing AAA 3D experience, we can drop our graphics onto there, our OBJs or FBXs or whatever. We can just drop them into there and they'll just kind of work. But for the time being, we need something to visualize this. So we're going to make a little player. So if you right click on the player, name in the hierarchy tab, you can just go and create another 3D object, and you can choose whatever you like. I'm going to make mine a cube because I'm extra boring, and you should see a cube appear. It's halfway into the floor, which is not terribly helpful. So probably the first thing we want to do is just move it up, and we can do this in one of two ways. You can either dial in the numbers in the same way that we were doing with the floor, or you can see there are these 3 arrows just here. You can just pull it to where it's a bit just above the floor. Either is absolutely fine. So now you should have some form of cube. I would like to make my cube a little bit taller. So I'm going to change the scale a little bit as well. And again, you can do this either by dialing in the numbers on the right-hand side, or you can do it in this kind of view panel by changing what these axes do. And you can do that by either using a shortcut. So if you go W, E, or R, it will change the kind of shape of those. And you'll find that R gives you these little square blocky handles. And if you drag one of those, you can change the scale, which is what I'm just doing here. So you can do it that way. You can, if you don't like using shortcuts so much, up at the top here, you can change it by clicking on these things. So you see you've got scale, rotation, and then move. You can do it that way too. That's also fine, whatever works. What is also going to be useful is, because we're going to make this thing move in directions, it would be quite good to know what direction is forward. And at the moment, all I have is a perfectly symmetrical cube, which is not particularly sort of indicative of the direction. So I'm going to give my player a nose as well. So I'm going to right click on the player in the left hand of the hierarchy, and I'm just going to add another 3D object, which is going to be another cube. I'm going to call it nose, just for fun. And I'm just moving it around a bit here, so that I've just dragged it up a little bit. I'm dragging it out, and then I'm going to change its scale so it's a bit more nose-like, like this. And depending on your level of proficiency, once we get all set up and we can kind of start messing around with things a bit more, you could start adding things. I could give my little person some little eyes as well, just for fun. But this is advanced level only. As you can see, this is very advanced. Anywho, enough messing around. Right. So you could click play now if you wanted to, and you would see that absolutely nothing happens. We can't even see the face of our player. If we click places, nothing happens. You can't move around the world. Pretty rubbish. So probably we should do something about that. So before I get into, we're going to write a script and start doing the nav mesh stuff. But before I get into that, has everybody sort of successfully created an empty object that's in the center of the plane, which is also in the center of the scene, and some form of like cube and cube combination that will visualize our player? Is everybody kind of happy with that?
Chris, can I just quickly ask, what's the shortcut for like switching to rotation or scale? Is there like a button you can hold?
Yes, there is. I'll just go over that again. So it's the top sort of keys, W, E, and R, will switch you between rotating, moving, and scaling. So you can just sort of kind of hit them until you get the thing you want. So this is rotation, and then R is scaling, and W is moving. And you'll also, maybe I should add that you can move things along axes like this and this, but you can also, if you grab in the middle of the thing, you can just sort of like move it however the hell you like, which can be useful. It's not something I use very much, but I think some people find it useful. And the same thing sort of applies for scale. Like you can scale this way, you can scale this way, but you can also scale kind of uniformly on all axes by grabbing the middle. And rotation kind of does a similar thing, but less so. You can sort of rotate according to the view, or you can do each of the axes. And you'll notice how the different colors here, see how there's in each one of these, there's a yellow, a blue, and a red axis. Same for scale. That kind of represents, that's quite a universal thing. It represents X for red, Y is yellow, and Z is blue. And you'll find I think in Blender, it's exactly the same. You'll find I think it's the same in Unreal. It's been a little while since I've used Unreal. That's kind of just a convention so that you know where in the world you are. All right, so if everybody's still in one piece, we're gonna kind of get into the weeds of this. What we need to do is we need to open a new panel. So if you go up the top, you should have a option for where you have like file and edit. You should also have a menu called window. And we just want to go in there and we want to go down to AI, which everybody should have, hopefully. And we want to add navigation. And then you'll see that on the right, you get a panel that says navigation. And we've got a bunch of things in here of different kinds that we're going to want to configure. The areas thing, just ignore it. Doesn't matter. The agent thing, we're going to mess with that a little bit, but not so much. For now, what we want to do is make sure that our plane here is something we can walk on. So if you select the Objects tab of the Navigation tab, you can just set it to Navigation Static, and you'll see that it ungrays this Navigation Area option, and it defaults to walkable. And we would like to walk on the plane, so we'll leave it as walkable. Great. So that's that part done. And then we also want to make sure our player will do some walking. So we need to add some form of AI to the player. So if you click on the player empty, the thing that is containing all of the objects, not the objects themselves, just the empty, then go to the inspector, you'll see that underneath the transform sort of properties, there's this option to add a component. So we're just going to click on that, and you can either go down to navigation here and click nav mesh agent, or you can click and you can search as well, like that. Either is fine, the result is the same. And you'll get this thing with a bunch of numbers in it. Looks super confusing. don't worry about it. Just leave them as default. Should be fine. And that's kind of all we need to get going. But what you'll find is that these two things don't know anything about each other. They kind of know each other exist, but they're not doing anything together. We have no way of controlling anything. Nothing's going to happen if we click play. So we're going to need to write a little bit of code, I'm afraid. But it's really the absolute smallest amount of code. So we're going to add another component to our player empty. Okay. And in this case, we're going to just search. This is basically a quick way to add a script. Okay, so you see you get this kind of default code in here, which says a bunch of things. Basically, you've got these two sort of functions, which will execute at different points during running the game. The one that says void start, you can see above it says start is called before the first frame update. What this means is anything within these brackets, so do things to set up game, for example, will run before the game sort of starts rendering. It will run when you press play. So these are things to do beforehand, things to prepare the game for whatever needs to happen. And then you'll see underneath we have this other thing called update, void update, and anything between these two brackets will happen every frame. It will do something every frame. So we're not going to use void update just yet. We're not going to do any updating each frame just yet. We're going to do some simple sort of tests of our infant navigation system. So in order to sort of do that, the first thing we need to do is we need to import the AI kind of library into this script. So we're just going to go up top and you can see where it says using system.collections, using Unity engine, etc. Underneath that, we're also going to type using, which is basically like saying import. I don't know why, anyway, yeah, it's basically saying import. So using Unity engine, and it's important that you capitalize things in the right place. So capital U, capital E, using Unity engine dot AI, and then you do a semicolon to tell it that it's the end of a line. And there you have it. So now we have access to all of the kind of AI stuff within this script. So we can tell it to do AI things and it will know what we're talking about. So inside of this first bracket here, the one that's just under public class, we're going to just start a new line. So just above void start and below that bracket. And then we're going to create a variable to represent the position we would like our little character to move to. So we're going to type public, and this means that the variable will be able to be accessed outside of the script. You'll see what that means a little bit later, but for now, just take that statement at face value. And the kind of variable we want to make is a transform, which is essentially, you know, that little panel in the right where you have your position, rotation, scale. This is the scripting version of that. So we're going to create a variable, a transform variable, and we're going to call it goal, because this is going to be the goal we want our AI to move to. And then we end that line with a semicolon as before. What we also want to do is we want to get a reference to the nav mesh agent we added to the player so that we can control it, so we can tell it to do things. So we're also going to create another variable, which is not going to be public, and it's going to be a nav mesh thusly. So just watch for the capitalizations there. And we're going to call this agent, like that. And that's all we need to do in that bit. This kind of area where we've just typed those two things, that's kind of where you sort of define variables and things like that. You don't necessarily assign them, you just define them. You just tell the program, look, you need to keep some space in your computer brain for a nav mesh agent called agent and a transform called goal. Okay, and the computer goes, okay, cool, and it makes some space in its brain for that. Okay, so now what we need to do is we need to just call one really simple thing in our setup, in our start function, to do as the first thing it does when the game is kind of ready to go. So the thing we want to do is we want to firstly tell it what this nav mesh agent is. So because at the moment we've just created an empty variable, it doesn't have any information in it. So we just want to say agent for our variable equals, and I'm going to inflict some really wacky sort of syntax on you. But basically what we're doing is we're going to tell it to just look on the object that we put this script on and find the nav mesh agent. So we're going to say get component, and then do these little sort of triangle brackety things. I forget what they're called. And then inside there, the component we want it to get is nav mesh agent. And then this is a function, so you have to put these brackets at the end, and then semicolon. Okay, so just going to go into my project. I'm just going to drop this script into here. And so in the chat, you should see there's a move to goal.cs script. So if anybody is really, I don't know, just having a hard time for whatever reason, you can just download this. And then what you would want to do is you would go find your project folder, wherever you saved the project. So in my case, it would be Super Smashy game. You want to go in there and you'll see there's this assets folder. And you can just drag it into there, or you can drag it straight into here, into your assets panel. If you're really not following stuff, that's totally an option. That's absolutely fine. So this is all the code we need to do to get things working in a really basic way. So we're just going to save it. So file, save. And then we're going to go back to our Unity window, and it'll do a little bit of thinking. It'll say compiling scripts, blah, blah, blah. It shouldn't take too long. And now if we have a look on our player empty, where we have the script component, you'll see now there's this variable, there's this option called goal, and it says none brackets transform. So this is telling us that that variable is now something we can assign in the editor. So we've just built ourselves a little tool, and it takes an object that is a transform. So it takes the position of something. Okay, so what I'm going to do is I'm going to create a new object that can represent that goal. So I'm just going to create another cube, and I'm going to call this cube goal, just for my sanity. I'm going to make sure it's above the floor by just setting the position to 0. I'll make it float a bit. I'll make it like that. And I'm going to move it around to be there, or whatever. You can put it wherever the hell you like. And now I need to tell my player about the position of this. So if you go back onto the player, what you'll find is that you can actually, in the hierarchy section, where it says goal, you can just click and drag the goal over and into that goal box that we have on our script and drop it, and it will just copy the transform into there. So hopefully everybody's had some degree of success with that.
So Chris, how did you get the goal up in the hierarchy?
How did I get the goal? Oh, how did I?
Sorry, I must have missed that. I was having trouble. I had to reload your script because there's an error in mine.
Okay, cool. No worries. I might have confused things. Maybe I'll call this object objects to find. This isn't the same as the goal in the script.
Is it an empty though?
I made mine a cube so I could see it.
Okay.
But you can make it a cube, you can make it a cylinder, you can make it a bulldozer. It's essentially, it's just, all it's doing is representing a position. So whatever kind of mood you're in is the shape it should be. I'm also just going to do a couple of like little quality of life things. One is that I'm going to click on my camera and I'm going to move it to a slightly better location. So I'm just going to, you can see that when you click on the camera, you get this nice little view of kind of how the camera is going to look on the right hand side. And then you can move the camera around using the little handles. I'm going to rotate mine a little just to make it a bit, actually that's kind of boring. I'll move it over here. I want to be able to see my, oh God, I want to be able to see my chap's face for extra style points. Okay, so just going to move it around. You know what? I think that's fine. Something like that will do it. Just so I can see what's going on. I'm also gonna, one of the things I kind of like to do when I'm starting to design these kind of moving things is it's not particularly helpful to have a blank plane with a cube that has the same material moving to another cube that also has the same material. You'll find that it quickly gets a bit confusing. So what you can do is you can click on your plane, for example. That's usually what I start with. And you can just add a new material. So the way to do this is to, I think you can do it this way. No. Is to just right click in your assets window and you'll see that you get this bunch of options. At the top, there's a create sub menu, and you can go into that and you can go down about halfway down this material. I'm going to create a material and I'm going to call it full floor. And then I'm going to just drag that onto the floor and you can see that absolutely nothing changes. But if I go into the options of the material, which we can see by just clicking on the material in the assets menu, you can see there's a bunch of different options. Most of these are, don't worry about them, but we could change the albedo by clicking on this little circle. And you'll see it opens up a bunch of things. I'm just going to change mine to this default checker pattern. You can see here that it's absolutely massive, which is not that informative. So you can also change the tiling if you want to. So I'm going to change it to be 10 by 10, which means it will repeat that pattern 10 times. If you were feeling extra fancy, you could also import a texture, like an image of any kind, for the ground. So I could also just import, this, and I could do the same thing again. I could just click and drag this image over into that little square where you can see the checkers, and then you've got some ground. And now it's going to be a bit more apparent where things are moving to. You can also do the same for these. You can start adding materials and so on and so forth. I could create a new material, call it player, and just add it to this guy. And I could make that, let's see, what colors can I see? Make that green or whatever, just so that things stand out a bit more. And also because it's a bit more fun. Okay, so that aside, we should be about where we're at, except for there's one more thing that we need to do, which is to just bake this. And you do that by going into the navigation tab and going to the bake section. And you'll see that when you click bake, the ground goes blue like that. And that's because it's, remember that we set it to walkable way back. We set it to walkable. It's the blue represents the places that the player can go. And so now we should be all set up. Messed up. I forgot to add a rather crucial part, which is if you go back to that move to goal script, you may have noticed and have been too polite to point out that I haven't actually told it to go anywhere yet. So inside the start function, we just need to add one more line, which is once the game starts, we want the agent to move to the position of the goal. So what we do is we just type agent for our nav mesh agent dot, and the dot kind of signifies sub options within a kind of an object. In this case, our nav mesh object. Our nav mesh object has an option called destination, or a variable called destination. So we go agent.destination, and that will change the place that the player is trying to get to. And we want to set the destination to goal.position. So that's the position attribute of the transform of the goal. And then we save it again. Want to open this back up, let it do its little compile thingy. If we've baked our navigation, if we've done all of that stuff, hopefully, hey, we get a cube walking to a cube. So really not a lot to write home about. What we have right now is incredibly boring. So, you know, it's just a straight line. There's nothing particularly like AI special about this. So I'm going to add a couple more obstacles. I'm going to add a couple more cubes. And I'm going to make these much bigger so that they start to form obstacles. So I'm going to make one that's like this and put it on the floor. I'm going to make one. I'm going to duplicate that. I'm going to move it round a bit. I'm going to make it a bit longer or whatever. We'll put that there. And then I'm going to sort of, let's see, I'm going to move this a little bit over to here. so that there's a bit more kind of navigation for our little fella to do. All right. Something like that will do. And as a convenience to me, I'm going to take all of these things that are going to be obstacles, and I'm going to put them inside an empty. So I'm just going to right click in the hierarchy, go create empty, and I'm going to call it obstacles. I think spell obstacles right. And I'm just going to take those 3 cubes that I just made. I'm just going to stick them in there. And then that means that I can really easily highlight everything in here. And if you look up the top, we can go into navigation and we can highlight all of these objects, and we can just set them to navigation static, like with the floor. But in this case, I'm going to set them to not walkable. And if I rebake the navigation, you'll find that you get this little like kind of bit that's not blue around all of that. See there? And then if I go and play, hopefully our chap should try and sort of negotiate that. So there he goes. Pretty snazzy. So what I would recommend you do is start experimenting with that. It'll take you a little time to sort of, I don't know, it depends on how familiar you are with 3D, but it might be a bit of a process trying to get this working to kind of put the blocks in place. So try building up some blocks. You could also sort of start experimenting with like how you would make something that the player could actually get up onto. So for example, let's see, I could do that by really quickly just making a sort of rampy thing, I think, like this, and then that down or whatever, something like that. Maybe it needs to be a bit longer. I don't know. Hopla, like that. You know, you could make something like that and then try rebaking it. And you'll see here that it actually can't walk on it, but if you set that object to be walkable, this object to be walkable, and then bake it again, you'll find that these start to go blue. At the moment, it can't walk up on it, which means you need to change some more variables. And in the bake option, you can start messing around with these variables if you like. So you can change the step height to be 1, which is how high a thing it can step up onto, and rebake it, and see now this blue goes all the way up. You can also change the agent radius and make a really chunky agent, rebake it, and now it's kind of can't really walk on anything because it's very large. You can also, if you had overhead things, like if you want to start making bridges or things like that, you could change the agent height to define where it hits its head, basically, and therefore cannot go through. I'm gonna, in my window, I'm gonna take my little object to find, and I'm gonna move it until it's on, I can see that it's on top of this sort of fat wall I've built. And I'm gonna move these things around a little bit, make this a little bit longer. And instead of this kind of crappy ramp that I've made, I'm gonna make some crappy stairs, I guess. So I'm gonna go and just duplicate this. I'm going to move it over, and I'm just going to move it down like that. And I'm going to make it a bit narrower so that I can make a bunch of steps. And I'm just going to keep doing this. I'm going to go Control D, move it over, move it down, Control D, move it over, move it down. Maybe I need one more step. Make these a bit shorter. Thusly, Control D, move it over, move it down. Okay, now I've got these cool little stairs. Wicked. So at the moment, these should, if I look in my navigation tab, all be set to be walkable. So in the object section, I can see they're set to be walkable. Great. So I should be able, if I have whatever I forget what the default settings were, it's like 0.4, wasn't it? So if you have the default settings and you go ahead and bake, everything should work, correct? No, not everything works, because the height of this here is higher than the step height. So the AI is correctly judging that no, this particular player is not tall enough or agile enough to step up onto this first step. But we can change that. So you can either do this by sort of experimenting with this number and just turning it up. So I turn it up to 1 and then rebake it, which works. Or you can actually go into your kind of transform options here and sort of work out precisely how high this is. But 1 worked for me, so I'm just going to use that. You'll also notice here that for some reason it doesn't seem to be able to calculate this part, and that's because these 2 objects are not set to walkable. So if I go back to the object options, you can see that actually it was set to not walkable, as was this. So I've set them to walkable now. If I rebake, then you can see we've got this lovely blue path going all the way to our object. So if I click play, we should find that he climbs the stairs. Hooray! Super cool. Okay. So now we've got a very basic kind of setup. We can start extending now. What we've done so far is we've made this we've made a really simple set of tools. We have the beginnings of like an environment with some obstacles. We've baked some kind of navigation to that so that we have areas that we can walk on and areas that we can't. We've set up a player character and a script on it that will go to a place. And that's kind of about it. But what we're going to do now is we're going to start extending our scripts a little bit, and we're going to make some stuff that's a bit more useful, because at the moment we've got an extremely short game. It's the kind of experience lasts as long as it takes for this cube to get to this cube. So it's not, so far it's not terribly compelling as an experience. So we're going to build on this kind of simple toolkit, and I'm going to sort of try and talk you through how to extend this. Yeah, let's just quickly set up some camera controls so that we can kind of see what's going on a bit easier. I think that's probably the best place to start, because that'll just make everybody's life a bit easier. So you'll see that in the scripts that I uploaded, there's a camera controller script. Feel free to download that and open it up if you import it into your assets and just open it up. Or if you are a glutton for punishment, you can just write the code like I will. So in my case, I'm just going to write the code. So I'm going to create a new component on my player empty called camera controller, and it's going to let me create a new script. And I'm going to open that. If you've decided you'd rather not write the code, I'd recommend still just watching what I'm typing out, because it'll sort of help explain what this script is doing, which might be useful in the future. So what we're going to do is we want to create a bunch of variables that will allow us to control the camera. So the first thing we want to, just realized I've created this on the wrong thing. Anyway, don't worry about it. So what we want to do is, in fact, no, this is going to be confusing if I do it this way. Let's just quickly go back here. So I've put this on the wrong thing. I'm thinking about it backwards, I think. So the camera controller script that I've just made, I don't want it to be on the player empty. So I'm just going to remove that. What I want it to be on is on the main camera. So I'm just going to click and drag it onto the main camera in the hierarchy, so that I have this nice little script on my camera, main camera. Okay. All right. Now back to the script, because what we're going to do is we're going to use this script to tell the camera to look at something. So we want it to be on the camera. That's the most convenient place for it to be. Cool. Okay, so we need to create a couple of variables. So in the same manner as the other one, we're going to create a sort of a variable to hold the thing it wants to look at. So we're going to say public transform, similar to the goal we defined in the other scripts. And we're going to call this target, and this is going to be the thing that the camera is going to try and look at. And we're also going to not type it in there. We're going to type it up the top where we put our variables. So I'm going to add a comment. So if you do these double slashes and it turns green like that, that's a comment. They're very useful because it will remind you what things are doing. We're also going to create a well, for the time being, let's just leave it at that, and then we're just going to really simply go and say in the update section. Wait, apologies. We actually want to do this in something called late update. So we're going to create a new function at the bottom here. Called late update, and this is another built-in function that Unity will expect to find, which essentially does this after everything else. This is important so that it kind of picks up the target at the right time. I wouldn't really worry about it, but in this particular instance, it's kind of important that you do this. So inside of this new variable we've created, late update, we can type transform dot position equals target dot position. We can also say that we want transform of the camera, so the rotation and position-y attributes. We want the rotation of it to look at. So this is like a function that you can call look at the target dot position. So basically, really simply, tell the camera to look at the position. And if you save this and run this, what you will find is once you drag a target into the target box that we've created there. So I've just dragged my player empty into there so that it knows about it. What you'll find is that we've got this very weird view, and what you might realize is that we're actually inside the player object, because all we've done at the moment is just set the position to be right in the center of the player, which is not very helpful. We want it to kind of move with the player, but we want to give it some like distance from it. So we're going to add a bit more to this script. And what we're going to do is we're going to add a couple of different variables. The first one we want to add is a vector3, which is basically a collection of 3 numbers which represent the x, y, and z. This is a little complicated, so I wouldn't worry too much if this is not making a hell of a lot of sense to you. So we're going to just get that, and then we're going to, in our late update, wait, how do we do it? Yeah, in the late update, we want to, from the target position, when we set the transform position to the target position, we want to subtract the offset. And what this is going to do is when we change the offset number, it's going to basically like move the camera away from that center point, but move it in relation to that target point.
Yeah.
So I can quickly show you what this does here. So I've added this offset. If I change it to, so if I change it to some random collection of numbers, you'll find that now it's moved a bit out of the way. These aren't great. This isn't a very good view, but you can change these numbers to be to your liking so that it will be kind of a certain distance away, like that or whatever. So in my case, I'm going to set this to 0 and set the y to, I don't know, there. That's fine, and the z to there or whatever. Or however you like, or like that is also fine. But bear in mind that when you change these variables here, the offset here, when you've clicked play, when you unclick play, it will revert them back because it sort of assumes that you're just testing. So I happen to have remembered the variables I put in, so I'm just going to type them in like that. So now we've got, you should find we have a camera that moves with our player and does some stuff. Great. I mean, also, you know, if you're really just having a complete mare, you can just copy paste the scripts, because this is, you know, this is the kind of script that I only write like once in a blue moon, because they, unless you're super into maths, this kind of like thinking is not that natural to me. I still find this challenging. So, you know, this is the sort of thing you write once, you copy paste it into a bunch of projects, which is why I sort of sound like I half remember most of it, which is because I try and avoid writing stuff like this all the time because it is a bit mind melting, but it's good practice. So as we can kind of only look from one sort of place. It would be quite nice to be able to sort of rotate around our character as well, so we can add some more control to this. I'm just going to create a public float, and a floating number is a decimal number, basically 0.5 or 1.8 or whatever, something like that. And I'm going to call this rotation speed, and this is I'm going to set this to 100F. The F stands for float. You have to put it at the end. That's the rules. I didn't make the rules. I'm also going to make a private float, and this means when I say private, it means that you're not going to be able to edit it in the editor. We don't want this to be exposed to the editor, because this is going to be used by the script internally. So we're going to call that private float current rotation equals 0f. And then in the update, so we're going to do these things before we make the camera look at the point. We're going to calculate some rotation-y stuff. So what we're going to say is that we want to set this current rotation value we want to make it equal, sorry, we want to make it minus equal to the input horizontal axis. And what this is doing is, this is going to probably seem quite abstract, is that there's a built-in sort of bunch of settings in the kind of the project settings that kind of default to defining certain keys as doing certain things. So you can call like a group of controls, which is quite useful. So here we're going to call the horizontal horizontal in this case is A and D, in a similar way to as you fly around the scene. And then we're going to multiply this by our rotation speed, because otherwise it's going to be incredibly slow. Because the get axis is going to produce numbers that are like 0.05 or something, which doesn't make for much rotation. And then we're also going to multiply this again. The little asterisks stand for multiply. We're going to multiply this again by time dot delta time. And what this does is it will allow us to for the camera to move consistently. The delta time tells the script how long it took to calculate a frame. So if you by multiplying this value we've created by delta time, we're multiplying it by the proportion of time it took to calculate the frame, which means that the speed at which this thing happens is going to be independent of the frame rate, because frame rates are a variable on computers. So if you didn't do this and it was just times rotation speed, you would find that on a really slow computer, your rotation would be nightmarishly slow. And then on a really fast computer, where you're rendering things at like 120 frames per second, it would be so fast that it would just be completely like unmanageable. So we just want to put this in to get a consistent speed for all the millions of fans that are going to play our game. Okay, so then we can pass this rotation onto our camera in the late update part of our script. So we can go transform, and then in this case, we want to call another function like look at, but this one is going to be called rotate around. And this takes 3 arguments. The first one is the point it rotates around. So this is going to be the center point that the rotation kind of happens around. So we don't want to rotate around the camera's center, because that will sort of, that will send the view like that. We want to rotate like that around a point. So we're going to say we want to rotate around the thing we're looking at, which is going to be the player. So we say target position to rotate around the target position. We also want to define the direction that we rotate, or the axis we rotate around. And we do this by just saying we want it to rotate around the up direction, and you do this by saying vector 3 up. Vectors represent a lot of different things. They represent positions, but they also represent directions and all kinds of other stuff. They're very confusing. They'll make you want to cry, but in the end, they're glorious. But for the moment, just accept that this is how you tell a computer that you want it to rotate around an arrow that's like a post that's pointing up, and just accept that fact. It took me at least 5 years to make sense of that. So don't worry about it if it's not making any sense. And then the third argument is how much we want it to rotate. So that would be the variable we created, the number we calculated up here, current rotation. We want it to rotate that much. We want it to rotate, so say this is like 2 degrees, we want it to rotate 2 degrees around the pointing up axis, and we want it to do that relative to the target position. Okay, so I'm just going to save that, and then with any luck, I won't have made any mistakes. And we should find that if you then play this, you can use the A and D keys to orbit around your player, so that now it's a bit easier to see what's going on, and also it feels a bit more interactive. It makes the world feel a bit more three-dimensional. So I imagine that a few people are probably going to have some questions and are going to be quite lost. So do people want to hit me with those questions?
I tried to write that script, but I got an error code back that says an object reference is required for the non-static field method or property transform look at vector. I looked at the script and I think it's all the same as the one.
No, that's cool. That's cool. That's cool. Let's work through it. So what line do you have that error on?
It's it says transform dot look at vector 3.
Okay, so in your script, this is the look at part, is this line, right? Can you see that?
Yeah.
It's this line that's probably causing you the issue.
Yeah.
So, and this line above, the target, the transform dot position equals target dot position minus offset.
I think I capitalized the T on transform. I don't know if that's why.
That will be why. Yeah.
Why.
yeah. Capital. The law of case sensitivity is a harsh mistress.
Yeah.
But don't worry about it. I mean, this is this stuff never ends. You'll still run into this because people make typos. We're totally fallible, and it happens all the time. So, when you start getting errors thrown at your scripts, find the line, because your kind of console error that you were looking at there will give you a line number.
Yeah.
So go to the line. Are the variables spelt right? Are the capitals in the right place? Is there a semicolon at the end? Have I closed brackets? 9 times out of 10, you will have made one of those mistakes. And it's just a case of changing it. That's not always the case. It depends, when you start doing more complicated things, you can get really horrific errors that will take you days to unwind. But for the most part, it's usually because you've made some form of typo, spelled a variable wrong, not closed a bracket.
Yeah.
So you should be up and running now.
Yeah, it's working now.
Nice. Lovely.
Chris,
Cool.
can I ask a quick question about the kind of like the cases and stuff? So in
Please.
in this code, so we've got like in the public class variables at the top, like transform is capitalized. And then in other places it's not capitalized. And some things are like camel case with capital at the beginning and some only in the second part. Is there like a kind of good practice logic to understanding which goes where?
Yes, there is. In some cases, I'm making a choice to do this because it's good practice, and in other cases, it is essential. So you'll see how transform and vector3 and that's all here are green, and then float and void and public and private are blue. These things are kind of internal to the language, and they will only be recognized. It will only be recognized that you're saying, create me a variable that is a transform object if you spell that way. If
mine's not green for those, if
okay.
I maybe not set it to recognize the language it's using somewhere.
Possibly. Did you get this code to work?
Yeah, it's all working fine.
Yeah.
It just doesn't have, it's not flashing up as those. I wondered if it was a thing you'd say personally, or if it was
Are you running on Windows or Mac?
Windows.
Yeah, okay, so this is like a thing that's the thing that's allowing me to sort of have all this nice syntax highlighting is something that's built into Unity, but it's kind of packaged with Visual Studio called Intellisense. It's a bit of a nightmare to get it working in Visual Studio Code, which is really infuriating.
Oh, no problem. No, I'm just wondering if what I'd done, if it was like a quick fix, because I think when I installed Visual Studio Code, it asked me what language it's going to be using, I think.
Yeah, I did manage to fix it in a version of Visual Studio Code. The reason I told everybody to install Visual Studio Code is because it's a very small package. It's a very lightweight piece of software, and because at least half of the people who do this workshop are going to go, I absolutely never want to write any code ever again to solve this. It's not going to be taking up, it's quick to install, doesn't take up loads of space, especially if people are working on laptops. But if you do get into it and you want that IntelliSense thing, which is really useful and is really worth kind of getting working, you can either look into getting it working with Visual Studio Code, which is possible but fiddly, or you can use Visual Studio, the full Visual Studio, which is way more plug and play. So if you use full Visual Studio instead, you'll find that it just works.
Oh no, that's what I've got. That's what I've got. Sorry, I've got that. Maybe I've just not told it what. I normally use Atom, but
of course, yeah.
Right. I'll have a, no, it's fine. I'll have a play around. I was just trying to work out what I'd done wrong, but like the code's all working. I just wanted to understand about the kind of, because I'm like totally kind of self-taught. I don't know what's good practice and what's not with all the cases. And I was like, if I can crack this, then I'd probably make way less mistakes. I understood this should have a capital, this should not.
Yeah. Okay. So the rule of thumb is that in C# generally, you do camel case for everything. And for anybody who's going like, why the hell are these two people repeatedly talking about camels? Camel case is when each word in a variable is capitalized, so it looks like a camel because it has humps in it, I think is the idea. That's what camel case is. And so you'll see here where I've kind of written camel case, but the first one is not capitalized. As a rule, I tend to write variables as camel case, but with a uncapitalized first word. As a rule in C programming, generally things like functions, like update, get access, look at, you camel case everything. So capital L as well as capital I. In the case of objects or classes, which these both are, transform and camera controller are both classes, you also capitalize everything. You don't necessarily have to capitalize this. You don't necessarily have to capitalize any of this. But it's good to have some consistency, especially if you come to a point of like wanting to work with other programmers, because it's good to have some level of like shared language. That
Definitely easier to read. It's really easy to spot like things.
Exactly, yeah. And it also, yeah. And you know, you're totally free to sort of grow your own form of that. Everybody kind of does. Like writing code has like, people have a style to it. So, you know, whatever works. But this is kind of how your quote meant to do it. But if it works, then you've done it right. So I wouldn't worry about it too much. Shall we move on? So I think we're going to leave the camera controller script as it is just now. For anybody who downloaded the one that I put in the chat, you'll find that there are a bunch of other options in there on it in the editor kind of window. Feel free to mess around with those to taste. What did I put in that? I think there was something to do with zooming, wasn't there, and things like that. Yeah. But for the time being, you know, our script kind of does what we need it to. We can see the scene. So let's move on to something a bit more fun, because at the moment we've still got our player is just moving to this cube, which is kind of a bit dull. So you can either take the have I screwed myself up here? No. Take the move to script, or you can expand on the move to goal script, or you can start from scratch. I'm going to expand on my move to goal script so that instead of moving to an object, it moves to where I click a mouse. Does that sound okay? Okay, all right. So I've just opened up that script I wrote before. And if you remember in this script, we have the goal, which we filled in with the position of that cube. We have the agent, which is our player. And then we get the nav mesh component from it. And then we tell that agent to change its destination to the goal position, and then off it goes. So that's all well and good, but it's not very interesting, and it's not exactly dynamic yet. So what we're going to do is we're going to create a new variable, which is going to be a vector3, and it's going to be called mouse position. And this is going to represent where we click the mouse on the screen and how it relates to the world, because obviously a screen is 2D, the world that we're working in is 3D. So what we're going to want to do is we're going to want to detect if the mouse is pressed. So we only want to kind of calculate this mouse position thing if we've actually clicked the mouse. So we do this by creating a sort of conditional set of code that will only execute if we do a particular thing. And we do this by saying if, and then brackets, open brackets like this. And we want to say if input dot get mouse button down. So if the mouse button has been pushed down, and we want the mouse button to be 0. So 0 in this case represents the left, main click. 1 represents right click, if I remember correctly. And then we want to open these like nice little curly brackets like that. And anything inside these curly brackets, just in the same way that anything inside the curly brackets of update, these 2 brackets, will happen once per frame. Anything inside these 2 brackets will only happen if this condition is satisfied. So if the mouse button has been pressed, things will happen here. So we can, I might add a comment to say if left mouse button is pressed. Just so I can remember what's going on. And what we're going to do is, when the left mouse button is pressed, we're going to sort of fire a line from the camera to the 2D point that we clicked on the screen, using something called raycasting. Raycasting is very useful. It's used for collisions. It's used for field of view calculations, bullet physics, positioning, all kinds of stuff. And essentially what it does is you shoot from a location, you shoot a little line in a direction, and usually you detect if it hits something, or you use it to measure distance or something like that. So in this case, we want to create a ray. So we go capital R, create a ray, and we're going to call this ray lowercase. And we're going to make this equal to our camera. So we can type capital C camera dot main. And so nobody should have changed the name of their camera. So if your camera is named main space camera, it will default to finding that camera when you type main. And then we want to type dot screen point to ray. And what this does is it does a load of maths for you, to do with sort of translating between the world of 3D and the 2D world of the screen, and how those two things intersect. Because for our eyes, because we sort of have creative brains and we can conceptualize, we can look at a 3D representation on the screen, put our finger on a point and go, that my finger is on the stairs. But that's quite a lot of calculation going on in our brain, and so we need to help our stupid computer do that calculation, and that's what this particular function does. So we're going to go screen point array, open brackets, and then we're going to say input dot mouse position. So essentially what we're saying here is we want a number that represents this ray point, a direction to fire, that is in 3D space, but based on this point that we've clicked on a 2D screen, translated through the kind of the camera we're looking at. I feel like I could have explained that better. There's something to that effect. Basically, turn our mouse into a 3D position that we can then fire a line from. And so what we also want to create is a something called a Raycast hit. This is another class, so capital R, capital H, and this is, and we're going to call this, I'm going to call this hit, and what this is going to do is we need to actually figure out when we hit something, because if we fire a ray out from a point, if we don't tell it to hit anything, it's just going to go on forever. It's just going to be this endless line, an infinite line. But what we want to know is what our mouse has kind of, quote, hit, which in most cases will be the floor. And so we've created this variable hit, which we can put a hit into. And then we want to create another conditional statement. So in the same manner as before, if, and what we want to do is we want to say physics dot raycast. So we're going to say fire a ray using Unity's physics engine, and the ray we want to fire is the ray we created, which we just called ray. And when we want to say the second argument is if a hit is returned, and we call this out hit. So if we hit something, give us back this value of what this thing is that we hit. And also you can set a kind of max distance, which is not terribly essential in this case, but we need to set it, so we'll set it. And in this case, so if you tried to click on something that was 150 units away, it would ignore it. The Raycast wouldn't pick up on it. Okie doke. And then we can open some brackets again, and then that variable we created, mouse position, we want to make that equal to whatever the ray we fired from our mouse cursor hit. So hit dot point. And now we have a position in 3D space that is defined by us clicking with a mouse on the screen. And I'm just going to add, I like to do this so for convenience, I'm going to add a little printout in our console of the main Unity window called debug. So we do debug.log to the console, which is very useful if you're having issues with scripts being broken. Try printing different bits of it out using this method. So I'm going to say LMB for left mouse button pressed, and then I'm also going to say hit dot point. And so what this will do is it will tell me that I pressed the left mouse button and what was hit, if anything, which might return an error. Anyway, and then after that, if we've kind of got all these numbers and they're all really useful now. We've got a mouse position. We know where the mouse is trying to click on in the real world, in the 3D world rather. Everything's great. We're having a good time, but we need to tell the agent to actually do something at this point. So what we need to say is, in a similar manner to the when we assigned the agent destination to be the goal position, the position of that cube we created before. In this case, we want to set the agent destination to the mouse position, but we have to do this using a function this time, because you can only set this destination variable directly before you start the game in the start function. So in this case, we want to say agent.setDestination, and we're going to set it to that mouse position value that we created. And with any luck, all will be right with the world and nobody's computer will explode. So save all that, compile your scripts, let it do its thinking. It might shout at you. Mine hasn't shouted at me. And in fact, just before anybody hits play, one thing we do need to remember to do is we've got some leftovers from our old version of the script, if anybody was following along with the typing it out themselves and extending the script. And one of those issues is that in the start function, we still have this agent.destination equals goal position. And if we leave that in there, as soon as we click play, it's going to try and find that cue, which we don't really want anymore. So I'm just going to comment that out. Okay, save it, go back to our game. Everything is wonderful. Okay, cool. So I've already got my script on my player empty, but if anybody else was creating their script from scratch, or downloading the scripts that I sent in the chat, then you probably want to just drag it across into here. Yours shouldn't have the goal variable. Mine does, because I've obviously left this in here. We don't need that anymore, really. And you should be all good to go. So if you click play, hopefully you can still orbit your thing, and hopefully you can click on points, and now you can move around the world. I can talk you through some of the other scripts I've left you with. So perhaps everybody might want to make sure that they grab all the other scripts and just drag them into their assets folder from the chat. And I'll kind of talk you through what the other ones do. Most of them are just extensions of what we've written, so they shouldn't be horribly jarring. Yep. Okay. So I'm just dragging these scripts that I pre-wrote. You'll see in here there's a bunch of other scripts. There's Bob, there is follow player, there is patrol, and there is spin. The ones that I think are sort of interesting in this example are patrol and follow player. Patrol will allow us to, if I create another object, I'll just show you how you use this. Patroller is patroller. Oh, I should probably create an empty instead. Create an empty, call it patrol person. And then I'll just make sure that's above the floor by setting that to 0. And then I'm going to add a sphere, and I'm going to drag that up a little bit so it's not floating. So I've got something to visualize it. And then I'm going to drag this patrol script onto the patrol person empty. So I've kind of created this in a similar way to the player, where you have the empty, all the scripts are on the empty, and then you have some form of graphic inside, which in future could be, I don't know, anything, could be anything else. But for the time being, it's just a sphere. And you'll see that in this script, we have a little variable here called points. And this is a list. And what this does is this will tell our our little sphere here, the points of its kind of patrol path. And you can create these points by creating a group of empties or whatever you want. So I'm just going to call this patrol points. Make sure it's got the floor. Don't know why Unity does that. It's really annoying. And I'm just going to set a couple of these patrol points. I'm going to make one here, copy it, move it over here, make another one over here, and make another one over here, or something. Make it there. Okay, so now I've got these four little points that represent positions. And so what I can do is I can populate this list I've made here with those points by, in a similar manner to how we drag the goal position onto our player's goal field. We can drag these patrol points into this list like this. You can see populates all of these. Amazing. And so the one thing we need to remember to do on top of this is we need to also add another component, which is a nav mesh agent, because this also needs a brain in the same way that that our player has a nav mesh brain. And we can define a bunch of things here, which I probably should have pointed out earlier. You can do the same thing on the nav mesh agent on the player, as you can define these things like speed. So I could make this guy really speedy sphere. You can change the angular speed, which is sort of how quickly it will turn to kind of orientate itself around things, which reminds me, perhaps I'll just add a nose to this fellow. Just give this guy a little sort of nose type object, some kind, so we know what's going on. Wonderful. Anyways, so you can change all of these things. This is kind of how long it will get up to speed. So you could give it a really high acceleration. Stopping distance is sort of the point at which it'll start to slow down. Auto braking is sort of whether it will kind of slow its movement as it gets towards the thing it's heading for. In the case of the patrol path, because it's wanting to sort of move smoothly from each point to the next, it's just sort of walking around in a circle, you probably want to turn auto braking off, because it'll slow down as it gets towards the things and then speed up again once it reaches it and moves on to the next one, which will look perhaps a bit unnatural. But you'll find that in the actual script itself that I wrote here, you'll see that it behaves very similarly to the other script that we wrote, where we have our nav mesh agent, and then instead of having a single transform that we're heading for, we have transform with these two little brackets, which tells us that it's going to be an array of transforms, which essentially means that make a list of this kind of variable. And that's our points thing that I populated. We also have this little counter here called destination point, which basically is going to keep track of which point in the list we're heading for. Is it point 0? Is it point 1? Is it point 2? Is it point 3? We're also, you see here that in the script I've turned auto braking off, so it doesn't matter whether we actually set it in the nav mesh component in the editor. And you'll also see here that at the start I'm calling this variable, this mysterious looking variable thing. This is a custom function that I wrote to kind of make this code a bit neater, and it's very simple. All it does is it sets the agent's destination to the next destination point, and then advances the number, the destination point number. And what happens is that this is triggered once at the start, and then in the update, we do a little test to say, is our agent, essentially this says, how close is our agent to our object? And if it's less than this amount, 0.5, move to the next point. So do this calculation again. I don't know how much sense that will have made to people, but basically we're just kind of repeatedly calling this function as it kind of reaches one of our target points. And you should find that when it's populated with a bunch of positions, just like I've done here, with the script, when you press play, it should just sort of walk around the scene. There we go. And it's quite a speedy fellow. See, and I've also put his nose on backwards, so it's a tail now. And it's also, see, it turns a bit more sharply than my player. What's kind of fun is you should find that I can sort of obstruct it, see it there? And it tries to avoid me, which starts to make for some kind of interesting, you know, that kind of builds on itself, and you can start creating some interesting stuff. And this in the same way to the other thing will avoid obstacles as well. So if I was to create a kind of wall in front of it, it will behave the exact same way as our player, and it will try and avoid this to the extent that it can. But what you need to bear in mind is that now that I've moved this here, in the navigation, you can see that actually it's not updated that. There's no line around it. So it won't, at the moment, it'll just fly straight through it. And if you find you're having that problem, you've created an amazing map and you've added all these new things to it and it's looking totally banging, but everything just flies through the walls, chances are it's because you've not baked the mesh, the nav mesh. So it doesn't actually know yet that these are things it can't run into. So you'll see this guy should be able to sort of, there we go, see? Lovely. And then in a similar fashion, you can sort of play with this patrol script in quite a fun way, which those eyeballs I made, those are essentially this patrol script that I've made here. But instead of trying to patrol a stationary point, I created 4 of these patrol people and set the point to be one of the other patrollers. So they would all be trying to patrol each other's position, which causes them to sort of like collide and move around each other in these quite weird ways, which creates a very interesting form of behavior. I'm going to make all the scripts and stuff in this entire project. I'll clean it up a bit and make it sort of available. So if anybody's very, very stuck, they can just start from here and play with this. There's one more script on here that I created that is an extension of the player script, which is that little pet that I created. So I could create another empty to use this pet sort of script, which will cause something to follow a player. And in this one, I'll give this a little object so that we can see what's going on. Make it a capsule just for a bit of variety. If I add this follow player script to this pet empty that I've created, you can see I've got these 2 little circles, and what these 2 little sort of radiuses represent is the radius at which this sort of pet will see the player and start trying to follow it, and the other one is kind of how far from the player it will sort of stop, so that it doesn't just walk into the interior of the player. And then below this, we've got the agent that it wants to follow. Oh, I beg your pardon. No, we don't. So let's make this a nav mesh agent like the other ones. This is the agent of itself. So this is this. And then we've got the player that we want it to follow, which is this. And you should find, in this case, we should be able to just, if I just take a little trip over here, this, yeah, there we go. Now I've got a little sort of capsule shaped friend that follows me around, which is quite comforting. And this is essentially a extension of the player's kind of raycasting mouse button click move to position thing, but with a couple more little tricks in it. So in this one, I've got these variables radius and stopping radius, and I've created this little function here to draw them, which uses this gizmos thing, which is just a convenience really, so that you can see what numbers you're changing. And then in here, I'm doing this thing called a coroutine, which is essentially just a way of saving performance, because I don't need to check how close the player is every single frame. That's kind of crazy. So I'm just going to do it sort of every, I don't know, 5 times a second or something. And that will be good enough for this pet to keep up with where the player is. And so you do this by sort of starting a kind of parallel process, which is called a coroutine. And the coroutine I start here is player proximity routine, which is this thing. And this is kind of what happens to detect things. So basically it sleeps for a little bit before it executes the code, and then it does this player proximity check, which is another function that I created, which essentially measures the distance between itself, i.e. this little capsule, and the player, which is the, whatever we dragged into this variable here in the editor. And then we just do a check to say, if that distance is less than the radius we defined, then we judge the player to be nearby. And in this coroutine, if the player is nearby, then we start another coroutine which tells it to follow the player. And so every 5 times a second, it will set the destination to the position of the player, the current position of the player, wherever that might be. And that results in, as the player moves around, this number position will update. And as a result, the position that the capsule is heading for will also update. And so you end up with this kind of like pet that will follow you. You could also in here, you could, for example, if you made this a bit slower than your player, you could sort of create a situation where you could extend the script, for example, by adding another kind of radius value, which would be like a sort of stop following radius, which would probably be bigger than this outer circle. And you could say that you could do another check in your script to say, okay, you have the pet following like this, but because I'm a bit faster than my pet, if I can manage to get like enough distance away, it will sort of lose interest and stop following me. Then you start following me again if I enter that inner radius. So those are kind of ways to extend those scripts. And also within this scripts, there's another thing going on which you can kind of use in other ways. Because essentially what's going on here is this is a script in itself that calculate the distance between this and this. And then if it's less than this distance around the player or the object or whatever it is, then do something. And you could set this to all kinds of things. You could set up a situation where this script is attached to a light maybe, and you run this check, and if something is close enough, a light turns on or a light turns off, or something gets bigger or something gets smaller, or something else happens. This in itself can do a lot of work in terms of making an environment things feel responsive. So within, it's worth taking a look inside of these scripts I've written. I'm sorry we didn't get to sort of really get into the meat of these so much today, and try and understand what's going on, because you can rip bits of this code out and start repurposing it for other things. But for now, I think we should maybe call it quit. And thank you very much, everybody, for bearing with me. I think Unity can be an intimidating piece of software, and hopefully you've got a single toe in the door, hopefully. Or at least decided that you never want to work with this ever again. Either is fine. It's not the be all and end all. So, but probably now it's time for lunch.